Hello and welcome to How It's Done. Before the early 20th century, wheels were primarily fashioned from materials such as metal or wood, providing a basic means of locomotion. However, the emergence of air-filled car tires marked a profound transformation in the automotive industry. Pneumatic rubber tires, with their ability to absorb shocks and bumps on uneven road surfaces, revolutionized the driving experience. The introduction of pneumatic tires was a game-changer for motorists, offering a smoother and more comfortable ride compared to their solid predecessors. The incorporation of air-filled chambers within the tire structure allowed for greater flexibility and cushioning, reducing the impact of road imperfections on both the vehicle and occupants. Moreover, the addition of tread patterns also facilitated better adhesion to the road surface, enhancing stability and control while minimizing the risk of skidding or slipping. Over the past century, car tires have undergone continuous improvement and refinement, driven by advancements in material science, manufacturing techniques, and tire technology. From the development of specialized rubber compounds to the integration of advanced tread designs and construction methods, tire manufacturers have continually pushed the boundaries of performance, durability, and safety. Today, modern car tires represent the culmination of decades of research and engineering excellence. They are engineered to deliver optimal performance across a wide range of driving conditions while prioritizing factors such as fuel efficiency, comfort, and longevity. As a result, drivers can enjoy a safer, more comfortable, and more enjoyable driving experience thanks to the remarkable advancements in tire technology over the past century. In each step of the tire manufacturing process, precision and attention to detail are paramount to ensure that the final product meets rigorous quality standards. The journey begins with the creation of a pliable rubber mixture resembling dough, which serves as the foundational material for the tire's construction. This rubber compound undergoes a series of processing steps, each aimed at enhancing its performance and durability. Polyester fabric plays a crucial role in reinforcing the tire structure, as rubber alone lacks the necessary strength to withstand the rigors of road use. This fabric is fed into a calender machine equipped with a roller that applies warm rubber to both sides, resulting in a rubberized fabric that provides structural integrity and resilience to the tire. Simultaneously, cotton cords extracted from bobbins are meticulously positioned onto the warm rubberized fabric, adhering at an angle to create channels for air venting during tire assembly. These channels play a vital role in ensuring proper inflation and pressure distribution within the tire, optimizing performance and safety on the road. Creating the rubber compound for the tire tread is highly specialized processes that involve the use of three distinct rubber formulations. Extruders shape the formulations into streams, which are then combined into one through a die, resulting in a uniform and homogeneous rubber mixture. Different colored stripes are applied to the tread surface by multiple paint rollers, serving as a coating system for ingredient identification during processing. To prevent tension and ensure uniformity in the tire tread, slack is incorporated into the feeding system, allowing for smooth and consistent application onto the tire surface. A blade slices the tread rubber to the desired length, ensuring precision and accuracy in the tire's dimensions. Meanwhile, steel cables are simultaneously uncoiled to form the bead, the part of the tire that provides the necessary strength to secure it onto the wheel rim. These cables are carefully arranged and encased in rubber before being rolled into hoops sized to fit the rim, ensuring a secure and stable connection between the tire and the wheel. Once the bead hoops are prepared, the tire assembly process advances to the integration of the intercomponents. A skilled worker utilizes a rotating drum to position the bead hoops precisely, laying the foundation for the tire structure. Following this, an airtight piece of rubber acting as an inner tube is carefully inserted between the bead loops, providing an additional reinforcement and support. The corded ply, consisting of numerous layers of reinforced rubber, is then carefully wrapped around the bead assembly to further enhance the tire's strength and resilience. With the inner components in place, the tire enters the next phase of production, where the outer layer is assembled. The sidewalls, crucial for providing lateral stability and protection, are affixed to the bead assembly by a specialized worker known as a surfer. Using precision and skill, the sidewalls are meticulously attached to the beads, ensuring a secure and uniform fit. Small rollers are then employed to fold the sidewalls over the beads, completing the inner structure of the tire. Meanwhile, the outer layer of the tire is constructed separately, beginning with the rubber strips embedded with the steel cord. These strips, designed to provide reinforcements and durability, are wrapped around a second tire building drum, forming the foundation of the outer casing of the tire. Narrow strips of rubber ply are then applied, carefully wound with precise tension by a computerized system to create a graduated effect. Once the outer layer is assembled, the two-tire construction, the inner assembly with the bead hoops and sidewalls, and the outer casing with the rubber strips are combined using a transfer ring. Compressed air is then introduced into the tire, inflating it to shape, ensuring that all layers adhere together seamlessly. As the tire takes shape, the edge of the tread rubber is rolled over the sidewalls, resulting in the formation of what we know as a green tire, an uncured tire lacking a tread pattern. At this stage, the green tire represents a crucial intermediary in the manufacturing process, poised for the final steps of production. With its various components integrated and assembled, the tire is now ready for curing, which will undergo heat and pressure treatments to finalize its shape, strength, and performance characteristics. Once cured, the tire will undergo final inspections to ensure quality and consistency before being prepared for shipment and eventual use on the road. Following the assembly of the tire's components, it transitions into the crucial stage of molding and shaping, where it undergoes a transformative process to achieve its final form and performance characteristics. The stage is essential for ensuring that the tire meets stringent quality standards and delivers optimal performance on the road. The tire is carefully positioned with a specialized mold designed to impart its desired shape and tread pattern. The mold consists of two parts that come together with precision, encasing the tire within its cavity. Inside the mold, hot, steamy bladders expand, applying pressure and heat shape to the tire and imprint the specific tread patterns onto the surface. This tread pattern is meticulously tailored to suit the intended use of the tire, with variations optimized for different driving conditions and performance requirements. In the case of summer tires, the tread pattern is specifically engineered to provide enhanced traction and stability on dry and warm road surfaces. As the tire undergoes molding, excess rubber is trimmed away to ensure a clean and uniform appearance. This process is known as deflashing, removes any protruding rubber and imperfections from the tire's surface, enhancing its aesthetic appeal and aerodynamic performance. Once the molding process is complete, the tire undergoes rigorous final inspections to verify its uniform shape, correct geometry, and adherence to quality standards. Skilled technicians meticulously examine each tire, conducting thorough visual inspections and using precision requirements tools to assess its dimensions and characteristics. Any deviations or defects are identified and addressed to ensure that only high-quality tires proceed to the next stage of production. With final inspections complete, the tire is deemed ready for shipment and eventual use on the road. Its rubber composition has undergone vulcanization, a chemical process that imparts strength, durability, and elasticity to the material. Through vulcanization, the rubber molecules cross-link, forming strong bonds that enhance the tire's resilience to heat, wear, and deformation. This transformation from a weak and sticky substance to a robust and elastic material is instrumental in ensuring that the tire can withstand the demands of everyday driving while maintaining its integrity and performance over time. The molding and shaping stage represents a critical milestone in the tire manufacturing process, where raw materials are transformed into precision-engineered products ready to tackle the challenges of the road. By leveraging advanced technologies and meticulous craftsmanship, tire manufacturers produce high-quality tires that deliver exceptional performance, safety, and reliability to drivers around the world. And that was all from us today for this video, folks. For more similar content, make sure to subscribe to the channel. We'll see you in the next one.